Hello and welcome to today's webinar, How to Implement NDR based on the AWS Well Architected Framework. Our presenters today are Vijit Nair, who is Senior Director of Products for the Cloud Portfolio at Corelight, where he focuses on building products that extend Corelight's NSM visibility into public and private cloud environments. Joining Vijit today is Roger Cheeks, who is a solutions engineer at Corelight and an expert in network analysis techniques and protocols, including packets, flow, Zeek, and logs. And with that, I'd like to pass things over to Vijit.
Thanks, Ed, and welcome everybody for joining us for the webinar. Today we thought we would go over sort of, where we think the NDR as a solution fits in sort of your overall cybersecurity stack, and especially for cloud security, how would you design a NDR solution that fits into the AWS Well Architected Framework? We'll go over reference architecture of how this will all come together. And for the most interesting part, we will go into a live demo at the end of the webinar run by Roger, where we will show a bunch of attacks and attempted attacks against our lab AWS environment. And you can see some of this data, a lot more richer data on our systems than you could on some of the cloud native solutions. So with that, let's jump into it. So NDR, just to set the baseline. When I think of cloud security today, mostly cloud security discussions around cloud security focuses on best practices, right? How do you secure your IAMs? How do you set up security groups? How do you lock down S3 buckets and so on? The aspect of sort of continuous visibility and continuous monitoring is just about starting to evolve in cloud security. And when I think of continuous monitoring in cloud security, it basically rests on these sort of three fundamental pillars, right? You think EDR endpoint, you think NDR for network, and SIM, where all the logs get aggregated, and threat and intel feeds that feed into all of these systems. Now, host-based endpoint or endpoint agents are quite common, right? And in the cloud paradigm, you're thinking mostly, where do you get your application logs, where you get your load balancer logs, where you get API logs, and so on. And these logs and this kind of data provides a lot of depth into the instances, into the applications that are running, how they're behaving, and so on. And especially if there is any attacker, activity going on in the endpoints, but they don't provide the breadth, right? And for that, you need network visibility. And network provides you, what I like to think of as a high vantage point from where you can get an eagle's eye view of your entire environment. And then obviously SIM is the logical place where all these logs get aggregated in, all the analytics run in the SIM, and you do your, you go through your use cases, be it incident response or threat hunting in the SIM. Now with NDR, until recently, network detection in the cloud has been very elusive, right? The reason is in a traditional network, you have a concept of passive monitoring with a cloud and with a tab and a span port, whereas in the cloud network that did not exist until very recently. So all you had to rely on were flow logs, right? And as we all know, flow logs are very much like NetFlow. They're not built for security. They're built for very basic monitoring of the network, so they don't give the kind of depth that your analysts need in your SOC teams to detect cybersecurity threats and attacks. But as of last year, several cloud providers, including AWS, have come out with their own cloud-native tab solution, and we are seeing a lot of folks interested in deploying NDR in their cloud environment, taking advantage of some of these native tab solutions. Right? So NDR, what are the components of an NDR platform? Right off the bat, you think of signature-based alerts, right? You want to detect your malware hash, you want to detect which C2 domain, known bad C2 domains systems in your environment are accessing. I think of this as your first line of defense, right? Your signature-based alerts, known IOCs are the first line of defense that you need. Unfortunately, these are good to have, but easy to spoof, right? So you need to make sure that any NDR solution that you put together has, in addition to signature-based alerts, has behavioral alerts as well, right? You want to see how attackers are behaving in your network. How are they SSHing into your network? What are you're trying to elevate the data from just signatures to TTPs that are harder to spoof, harder to evade. You're looking at what kind of tools are they using? What kind of exploit tools are they using? What kind of authentication mechanisms are they using to get into your SSH? What kind of certificates are they using to authenticate their access? These all sort of flump into behavioral-based analytics, and depending on some of these behaviors, you can generate sort of high-quality alerts from your environment. Now, once you have these alerts and insights, the next step obviously is you want your analyst to be able to triage it. And for that, you need extremely high quality, high signal data from your environment. You need context that is very relevant to the alerts that have been generated. And this is where a lot of the NDR solutions fall apart, because the data that you need needs to be very specific to your environment, data that can be enriched within your environment, based on be it whitelists or blacklists or CMDB or whatnot. And this is the context that analysts can use to do incident response and threat hunting, right? And finally, once you have beyond investigation, the absolute last line of defense that you have is raw packet capture. Obviously, nobody likes to go to raw packet capture, but there will always be a case, there will always be an instance where you have all but some specific data that you need. And for that, you need to have some level of packet capture, and you need to ensure that the NDR solution has is able to retain the kind of data that you need for as long as you need it without blowing out your budget, without blowing your bank, right? So this is sort of how I think about what are some of the key components of an NDR platform. And we've been talking to some of our key customers out there. These are sort of large, sophisticated enterprises that have been deploying NDR solutions for a while. And when they deploy an NDR solution in their environment, they are trying to replicate a very standard design pattern. And most likely, the design pattern is typically based on open source solutions, right? Because open source solutions gives them something that is non-proprietary, something that they can actively build on, and most importantly, it gives them the community feedback, right? It gives them a lot more sort of active collaboration and development in the community that they can bring back into their environment. So be it any new exploit or attack that comes out, there is a community development to detect that in the environment using these kind of tools. So the design pattern for an NDR looks something like this. At the bottom you have a tap or a span port that's usually fed through some kind of a packet broker. In case of AWS or any of the cloud providers, it'll be the native cloud native tap. We call it traffic mirroring. This will feed your passive visibility stack, right? So now we're talking passive visibility, not active visibility, not firewalls and IPSs and so on. These are the passive visibility tools that give you, something like Suricata that gives you signature-based alerts, something like Zeek that gives you signature and behavioral-based alerts. Something like Zeek that provides a lot more data. In addition to just alerts and notices, it generates a lot more data, structured metadata that is, looking at the protocols that are running in your network and bubbling up what is very germane, very relevant for security responders, for incident responders. And finally, you have something like PCAP that is able to selectively capture packets in your environment. And then finally, a lot of this data collects up into a SIM where the responders themselves can either run analytics on it or run active